So, edition number 7. Today we have on our agenda a few things. We would like to highlight to you something I discovered this week around timestamp time generated within log analytics. Then I want to briefly demonstrate the capability that was introduced earlier this year around Sentinel Data Retention, Archive, and Restore. Don't worry, I won't go into much detail. I rather want to show you some of the, let's call it end user experience when we are retrieving log files and restoring and searching for them and how those things look. Then last week, Microsoft released a guided hunting in Microsoft 365 Defender, which might help one or the other who is too lazy or who is a beginner in KQL to actually write KQL code using a GUI. Then we continue with IOCs. Johnny will talk about a new operator called parse-kv. And then, yeah, finally, we have a very special guest today with us. And lastly, as always, we will briefly talk about what we did with KQL in the last month. So let's get this started. So the very first thing I want to briefly mention, and that is a capability called Sentinel Data Retention, Archive, and Restore. And what that basically allows us to do, that might be especially interesting for people using Microsoft Sentinel, is basically to, until now we had the option to set a data retention time if you were just using log analytics. You had 30 days for free. In Microsoft Sentinel, retention is up to 90 days. So we're basically, paying ingestion costs. But if we wanted to keep the data longer, until last year, the only option we had is to maximize the data retention for the whole workspace for up to 2 years. But depending on the size that you are ingesting through Microsoft Sentinel, let me give you a rough idea from my experience. Average company between 2,000 and 4,000 users, full stack, Microsoft 365 Defender ingestion, Azure Active Directory log data, Office activity, although that one is free to ingest, Azure activity, the same. Nevertheless, you can easily come up to between 20 and 40 gigabytes a day of data. And of course, if you have an E5 license, Microsoft will give you some credits for that, approximately 5 MB per user per day. So that might cover, depending on how noisy your MDE, Microsoft Defender for Endpoint environment is, which, a client submits between 5 and 15 megabytes per day. Nevertheless, you come up with quite some gigabytes. Now, with the data retention, archive, and restore, we now have the ability to actually, if we want, on a per table level, as you can see in this screenshot, configure how long the data shall actually remain, let's call it, in the hot log analytics database, and when log analytics is going to move your data into an archive part of the log analytics system, allowing you then, if you need to get the data back, to actually search for data, and even if you wanted to restore data back, because after you did your search, you have identified the user or the tables that are of interest for your investigation or for your auditing purposes. And now what you can do is actually bring back the data. So let me quickly show you how that looks when we are in Microsoft Sentinel. And hopefully things fly again, because as you might have noticed, It was a very boring day for us today because we couldn't do any KQL, but it looks like things have recovered. So what we have here is it's called search, and it's still in public preview. And let the demo gods be with us. So as you can see, I have here my interface, and what I can do in the first instance, I can run a search. So in this case, I was interested in device logon events from this particular user. And then when search was finished, I am able actually to look at the data because now that data becomes available in my log analytics workspace. And what it does, it actually creates a custom table in your log analytics workspace. Let's jump directly into the log analytics workspace instead of making a loop through Sentinel. And we go to logs. Okay. And as you can see, there's a search
Alex,
result. Yeah.
You are sharing your PowerPoint and not your screen, probably.
Oh, that's a typical Alex problem again. Okay, so let me share my screen again. Let me know if that works.
Yeah, that works.
Okay, yeah. So yeah, what I was actually describing before is that here within Microsoft Sentinel, I have this blade called search. In here, I can run my searches. And when a search has results, what actually happens is that, I now get a table, as you can see here, device logon events. My search was very specific, on any device logon events from this particular user. So what I do get back is actually, the search results from that time. Now, what I have to do, because I did a search that went way back, actually, I had to wait a little while until I could even experiment with this solution until my data was actually archived. And as you can see now, I only get in my search, the data from this particular user. Yeah. Okay. So as a next step, I actually decided that I wanted to do a so-called restoration of data. So if I want to, really do a restore, what I basically do, I say, okay, create a restore. Then I can select the table I'm interested in. In this case, any table that I have included, I can define the period when, I'm interested in. And this will be typically, the period where your data is already in archive mode. So your data is no longer available in log analytics by means of, in this case, I'm interested in the Microsoft Sentinel and in the device logon events, right? But if we take a look, and actually I had prepared all those queries here. Let me quickly get them. Yeah, here we go. I could have, of course, saved them beforehand, but I didn't do so. So I'm now interested in device logon events. We will notice that, these are the most actual data I have. So from July, yeah, now I do the same in search. Of course, nothing. So I have to go back to whatever I have defined there. Oh, what's wrong? I should have clicked the right button and say apply. Okay, I get that data back. Yeah. Okay, and now I actually want to look at the restored data. So I now have to, do the same here. And my restore was exactly, the period between the 28th of April and end of March. Yeah, so that is now back in my hot cache, and I can now use the data. Yeah. Here the same. Now, an important thing to know, and you should be aware of when you do those restores, is that if you look here at the time generated, you will notice that if I do a project time generated and a rich, where was it? Let me quickly see. Now I'm lost. But what I wanted to show you is that argmax time generated. Where was it in the search? And when I did my restore, okay. Let's get schema. You will notice an attribute called time generated, and I actually wanted to show you another attribute. I'm totally lost because that was called original time ingested. Here we, oh no, sorry, it was in the search table. Yeah, okay, this one. Okay, so let me correct myself. If you are restoring a table, you get exactly a copy of the data. But if you are searching for results, there be mindful of the following, that if you want to join the data, that we now have two timestamps. Yeah, we have the time generated, which is actually the time when I did my search, and we have the original time generated, which basically relates to the original timestamp of the event itself. Yeah. So yeah, that was basically what I wanted to highlight here. Yeah. Good. So that's, a very brief overview of, the search. Of course, we could run a full session on it. I can also recommend, and I will add it to the show notes. There are some great videos on YouTube from the Microsoft Brother team explaining all the ins and outs around, search and restore. But I thought in terms of KQL, querying data, I'll give you those a few examples and share my findings. Yeah. Good. Next one, Defender 365 guided hunting. So what we have here since a couple of days in public preview is the following. If we go to advanced hunting here, honest, not sure how many of the seasoned KQL people will use this, but to be honest, we always make this comparison with PowerShell, KQL. There's a learning curve. I mean, there's tons of examples out there if you query GitHub or look at blogs. Nevertheless, of course, this might come in handy for people just starting, creating. What we now have here is an option called Query Builder. Yeah, and when I launch the Query Builder, what I actually get now here, I get some guided help. So I can first of all choose, what I want to query. So let's say I'm interested in endpoints, and then I have some examples. So, change local group, right? And what it does for me, it basically, automatically prepares in a visual style my query. Yeah, I can now go further. Let's first run this query. And of course, that's not going to give me any data because I don't have any groups created in the last 30 days. Did I? Oh, yeah, actually, I have. So I have one result back. Yeah. And if I were only interested in, let's say that particular thing, let me see what happens here. Of course, now you cannot say, add it to your query, just copy the value to your clipboard. But now I can say, okay, add a filter. Yeah. And I can select here from the filter and I can go to, device events. Yeah. And here I can do some further filtering. That is, of course, a stupid example. So let's go here and I can, use this and I can say, okay, I'm only interested in, and now I could enter my device name in here and basically, through the UI start composing my query. I mean, and when I'm done, I can of course also say, edit in KQL. And what it will do, it will basically, change my whole query into a KQL query. Yeah. Okie dokie. You find the announcement here. And then we move on to Johnny.
Yes. So let me share my screen. Yes, one of the sessions before, I discussed some filtering about ASN, but it's got kind of complex because if you have an ASN number, then you need to find out which IP addresses belong to it. And when you have the IP address, you have to add it to a list, a watch list, or add it as a threat intel even. But since I think about 2 or 3 weeks, I found out that in the SigninLogs now, then you can use also the ASN number. So let's see. Over here we have the list, and the team recently added the column autonomous system number. So instead of hassling with all the IP addresses and stuff, you can feed a list of ASN numbers from your query, or also you can also create a watch list for specific ASNs. For instance, if you don't expect traffic or sign-ins from abroad, or if you want to maybe add trusted ASNs, for instance, you have a single brand for as telco, so you know the ASN of them, you know the ASN of your VPN provider, you know the ASN of your internet providers. Then you are able to add those as a list, and then you can filter on those, or you can create an exclusion of those, so you can quite easily see what's happening. And you can also use the ASN to do a bit of anomaly detection, because users tend to switch IP addresses quite a lot, because if they move from a cell tower, or if they plug their laptop in a customer's network or in the office, then they tend to help a lot from IP addresses. But the ASNs are broader, because an ASN is between thousands and several million IP addresses. So that's my the thing of IOCs I wanted to show today, is that you can use ASNs to filter traffic, or in this case SigninLogs actually. And one of the list you can use is the botnet ASNs from Spamhaus. And I've also added a link in the slide deck, and they will also be in the show notes. So that's the easy one. And then for this month, the last couple of weeks, I've been working a lot with parsing data, and one of the parsers, which is quite new, it got introduced back in June, and it's the parse-kv, and it's key values. And a parse-kv is faster than if you do an extract or if you do a normal parse. I will show you that it can be less complex, and because it's less complex, it's also less error prone, because you can play quite easy with it, and it's also it can give you really clean KQL code, and you don't have to use complex regex statements. You can if you want, but it's not needed. Let's go over here. Because in the beginning, what I used to do is if I wanted to get data from syslog, for instance, I'll display some lines. And this is from my test environment where I have some traffic, some network duration, some send bytes, some receive bytes. And for instance, for an ASIM parser, it's really nice to grab the duration, the send bytes, and the receive bytes. So in the old days, you used extract to get those. And it cuts it really clean because you have a space at the beginning, so you can do a regex space or you do a normal space. And then the same goes for the network duration, for the send bytes, the receive bytes, and you get the values. But when we look at the performance of this query, it takes almost 600 milliseconds. It will use some memory, and it's not that clean. And this is just from my sample environment. So there are about 400,000 records, and it's a bit slow. So the faster way to get the network data, the duration, the send bytes, receive bytes, is to do parse. And with parse, you can create a single line. You say, hey, I want the network duration, and when it's followed by send bytes, then I want the send and then the receive bytes, and then I declare the value receive. So this is a bit faster. It looks a lot cleaner, and everything is nice. When we go also to this query details, we see that the milliseconds, it's almost halved. So the performance is a bit better, and you get also the same data. The thing is, if you run your query like this, then it has to be in the same order. So if someone moves a bit around in the syslog message, if they maybe moved the network duration to the back, then this won't work anymore. So the next generation of parsing is when we use parse-kv. So in parse-kv, you can, of course, select the syslog message, then use the duration, send bytes, receive bytes. And we state over here that the pair delimiter is a space. So if we go to the syslog message, where do I have it? So over here you have the duration, and then there's a space in between here and a space in between here. So the operator knows where to cut it. The splitter, it's the delimiter from the key and the value is the is sign. So that's also nice. And the quotation around the values is the double quotes. So when we run the parse-kv, it will automatically find the key values that we set up. So over here, and Let's add the where is not empty. That's because by default it grabs the key names and it doesn't rename them because we haven't given that operator yet. And we do it like this. Take a couple of seconds. Some more. It's actually taking a bit longer than I would have expected today.
That's because you have to reboot all the systems.
Yeah. Let's try it again. This is.
That's a real demo, right?
Yeah. The thing is, this should have been faster than the. During testing.
It could be down to the incident we had today. It could be down to that because I checked the service status. It's still being investigated.
Okay, well, what I heard was that it should have been solved, but maybe the team is still working on it, or they have to still write a post-mortem to find out what exactly happened.
Could be.
As far as you trust me, I saw it last night when Johnny showed it to me, so it was definitely faster. But maybe just go on and also highlight the other benefits beside the performance. Yeah.
So if we do without, we have it over here. And then if we go to the query details, you can see that over the same time period, the CPU time was only 15 seconds that it actually took to collect the data. So if you look at plus 500, plus 300, and just 15 milliseconds, this is way faster. So also if you have like a really large data set, because this is my own demo environment where I tested some firewall login. But if you collect like 40 gigabytes a day and you look in 90 days because your retention is free for 90 days, then this will be a lot faster than just doing a normal parse or extract. But now the columns aren't that nice. So what we'll do is we'll rename the columns with a project rename. And then we should, it's fast again. That's nice. So now we have the normal ones, just like we did over here. And also, if we look at the query time, you can see it's still a bit faster than when you do just a plain parse. And the good news is these values don't have to exist in every message. So what we can do, some other fields are geo destination, geo source, users. We can add everything to the mix. And also good news for this parser is if we look at the message over here, we have the message ID in the beginning. But because it's looking for keys and values, I can also add it somewhere in the middle. And this will still work. So if you have, if they change your, if the vendor changes the way they send the logs, or if the team modifies, for instance, the Ceph where you can adjust, for instance, the order of the fields, then you are still able to quite easily parse the message. And over here we have all the fields that have been parsed. So for instance, we now have the destination geo country, and some fields have the duration. So with parse-kv, you can parse it quite easily. And also, if you like regex, or you need regex because you are missing the delimiters, or you don't have the key value separated like you expected, then you can also use regex instead of the parse-kv delimiter and the quote. So this is a really nice and fast and easy way to parse complex data. And also, yeah, it's working good. And also, just over here, we have parsed all the records in 62 milliseconds. So it's nice and fast. And that's my bit for today.
Maybe go back quickly. So, you did a great thing. So yeah, why doing this? First of all, as we saw, it's faster. It might also help, to make your queries look less complex. If on every line you have to do this parse, extract, and whatever. So if we look at the last bit of code, which of course, as always, we will share, you look at it, less error prone, right? So, if you have to make a change, it's quite readable of what's happening there. And last but not least, what was the last bullet we figured?
Clean.
Yeah, cleaner KQL, so easier to read when you actually have to look at your colleagues' KQL queries. Yeah. Great. So before switching screens again, if you can go back to the slides. Yeah. So next, just, I saw this during the weekend, someone tweeted this. Nice search for on Microsoft Learn. If you search for this, you basically get all the learning modules from the various, certification paths, where there is some piece of learning and experimenting with KQL. Yeah. Great. And then coming up next,
the most important slide.
Yeah. So we're very pleased today to have Aswin Patil, I hope I do pronounce your name correctly, with us. And I suggest just introduce yourself, and the floor is yours.
Awesome, thanks. Can you guys hear me fine?
Okay. Yeah.
Good. Yeah, so let me share my screen and then can go for the introduction. Yeah, so yeah, thanks again for thanks for having me. I think it's really great to chat with the community closer and then check out all the progress that's been going. The KQL community has really grown exponentially, like since last 2 years. So starting with my introduction, I think my name is Aswin Patil. I work as a senior security researcher for Microsoft Mystic team. So I primarily work on a range of things from detection, development, like writing KQL queries, publishing to Sentinel repo, and also like working closely with the Sentinel product team on various features related to threat hunting, so that we can provide threat hunters view and then integrate those features correctly for the customers. Apart from that, I also do some development along with our broader team. Like you may have already known Ian, Pete, about the Mystic Pi, and then publishing some Azure Sentinel notebooks, which again is like another way to do the threat hunting on the Sentinel data. And the Mystic Pi libraries basically allows you to connect to Sentinel as well as other same data sources, so that you can do similar type of data analysis techniques on the other data sources, right? So for these presentation, I think rather than like picking up a like very specific KQL topic and talking about it, I thought it will be a good idea to do like a updated version of the talk that I did on a couple of years back at the Grey Hat. So it was titled "The Blue Teaming with KQL." I've heard like pretty good feedback. Like several people reached out to me via Twitter, and I also seen like some tweets related to like some. It has been like proven helpful. Some of the things that have been changed, I think some operators have changed drastically, but the framework was, I think, still being useful for the defenders, right? So for this presentation, this is what I was thinking to do the agenda. So if you have not seen Grey Hat talk or my GitHub repo, I think I'll do a very quick introduction about the what was covered in that talk, what's the framework looks like for the defenders or someone who wants to do blue teaming with KQL. So mostly like in relation to Sentinel security context, doing threat hunting, that sort of things, right? And then for this presentation, again, like as I was talking earlier, rather than picking up specific things, I think one of the things that I think probably this is again like from my experience that I've seen is when analysts or like defenders are new for the KQL language, they kind of start as a first step to get familiar with the syntax. If they have not been in the SQL, there's like much more learning curve for them, right? Once they get familiar with the operators and other things, then comes the detection engineering or the hunting techniques, right? Which is slightly different. Again, like if you came from like other tools and technologies, I think the way you write queries is much more different, right? It's not just about if you know the operators, you can just munge it and then create a query, right? So there's like still a little bit of knowledge or like research is involved in understanding the schema, parse, extraction, and also like various techniques, like so that you can get the data that you want and then write detections for those things, right? So we'll talk a few examples like that I've basically picked it up from our Sentinel repo, just to understand like what are the category of queries that we write when we publish into our community, the public Sentinel repo. So that will probably again kind of help you in understanding like how to go about like actually writing the KQL queries once you are familiar or like mastered the KQL syntax, right? And then I have like a couple of things that I'm basically categorizing into extending KQL section, which is basically sometimes KQL does provide you a lot of great capabilities inbuilt, but they do have like some limitations. So how you can basically extend that KQL with some other technologies and then still perform some hunting with KQL, right? And then we'll conclude. So, okay, let's start with the talk recap. So this is kind of like a you can say like mini workshop kind of things that I did within 40-45 minutes. So the goal for that talk was to give you an introduction to a new language and why you should learn that query language, and then how to go about like probably rather than learning the language as a whole, how to pick up like several sections and then start understanding those sections. So I picked it up a few again use cases that we know we have to use it quite often, right? So these are like kind of sections that you can start with like how to understand the basic KQL queries, searches, exploring tables, how to go about like asset inventory, then query parameterization. So this is then going along and understanding like how you can leverage the KQL things. And then some of the operators like the regex extraction, like IP, which is right now, like now we have like a built-in KQL operators. But previously, I think when I did the talk, like we had to parse and extract out the IP addresses via regex, right? So some of the things have really evolved since then. Apart from that, I think there are like few things that I also covered about the functions, external data. Again, some of these things, if you have been this podcast listener and been using this language, I think you may be already familiar with that. And then I think lastly, I covered a couple of use cases, which kind of like a bit kind of intermediate level where we use the native built-in time series anomaly. Some of the operator like previous, next, like how to use that for finding out the beaconing patterns, and then some of the programmatic interfaces using Mystic Pi, right? So if I will probably quickly show, like if you go to the GitHub repo, I think I have a so you can basically navigate various sections for the repository. So for each of the sections, we have like a sample queries that you can basically copy and paste in your workspace or Gusto Explorer to understand like how it works and all the things, right? So apart from that, I have like good visualizations as well, like to understand where is data types. So often we encounter the data types in the form of array or dictionary, right? So how do we go about performing several actions on those data types, right? So it's not just about probably passing out. Sometimes you have to, let's say, manipulate or take aggregates, some other type of operations, right? So these are kind of like hand-picked operators that I associated, which is often used mostly in threat hunting and other scenarios, right? So you can check out this repository, and then the presentation is also in here, and then the video is also there, right? I'll update the today's slides and some of the queries that I've talked about in the same repo, so that I don't create another repo and then move around stuff elsewhere, right? So that was like a quick recap. So yeah, so this is, let's talk about the probably current session topics, right? So as I was talking about earlier, once you get familiar with the KQL syntax, operators, and other things, I like, this is again like my personal experience, right? When I learned KQL, and then when I started reading some of the queries that other people have written, they were like much larger, much complex in nature, right? So if you're just getting started with KQL and operators, I think your queries may not even go beyond like probably 5 to 10 lines, right? That gets the job done for you in most scenarios. But if you have to do like a kind of like a complex detections or the threat hunting query, I think your queries tend to go longer and much more modular. Some of the things that you have to keep things into mind, keep in mind while compiling those queries, right? So these are kind of some of the issues or things that often comes as a learning step for defenders, right? So once you learn the language, how do we go about like practically implementing that knowledge into your day-to-day life, right? So the larger complex is another issue. Again, if you are being new to the SQL and database world, I think it's there's like a lot more new stuff that you have to learn, right? Joining, interjoining, left join, right join, and a bunch of other joins, right? Um, uh, and then lastly, this is again an important point that I wanted to highlight is some of the times the analytical questions do not translate directly to the language syntax, right? So let's say even if you know that what you want to query in your data, and then once you and you're familiar with some of the syntax, I think you still have to do some data preparation before writing the actual queries, right? So that may involve, let's say, what for certain detections you don't have the data available in single table. You have to join it with other tables, understanding like which field it has, and then basically parsing out, extracting, and then joining that data, and then creating the final data set, which can be helpful for finally writing the KQL query that you wanted to write, right? So we'll see a few examples that I think I've extracted that will help you to understand and grasp this concept. Right? So, so this is like the few categories that I think I basically extracted, which will probably kind of help me to convince you like it's not just about the understanding the operators, like how do we go and then put compiling the query along with some innovative ideas, right? So I've basically named this section as practical detection engineering hunting with KQL. Again, I think for simplicity purposes, the detection research part is like much complex, right? Like actually researching the technique and understanding like what data sources it has and then what logging it has, right? So that's kind of like the first step. I have not covered that in here. I'm assuming that you have done the that research prior hand, and then now you have kind of pseudo logic that you wanted to put forward into like a detection query, right? So I basically came up with these three or four categories, and then there are much more categories are there. But most of the detections or the queries that you have seen in our public repo are kind of like a combination of these techniques, right? So we'll start with like the first one, which is pretty simple. I think you should be able to do this on your own. I think once you have done the KQL syntax and other things. So it's just about like aggregating and implementing some threshold-based query, right? So let's take an example of this scenario. So again, if you see my other talk, the way that I've structured this talk is basically picking up this sample query, which is like a practical example that lives into the Sentinel repo, and then basically decompiling and understanding that query from a defender's point of view, right? So for this particular category, I have picked up these detections that we have in our public repo, which is basically doing a suspicious enumeration using ADFind tool, right? So now, for these detections, we did we did some research prior hand, and then we know that sometimes what happens is the attackers actually drop a defined tool with the renamed with some other names, right? So you cannot just basically look for an adefined.exe and then basically call it done, right? The techniques that were basically leveraged was any tool that can perform a defined activities, but it will not be named as defined, right? So the purpose here is to check like what are the other characteristics of defined that we can detect, right? So here what we are specifically looking for is some of the command line tokens, right? So defined allows you to specify these kind of arguments into a command line, which gets logged into a 468, right? So if you notice here, I do not have a filter for specifically looking for adfind.exe, but I'm looking for these strings into and command line as a token, right? And then this can just like we are not finishing our work like by looking for these command line tokens within any processes. In order to make it a much more stricter criteria, what we have done is like we have implemented this criteria where we are basically looking for, let's say, more than 3 individual commands with those command line tokens within 2 minutes. That can be like per account or per computer, right? So here, if you notice here, like we have a couple of variables here, lookup window and threshold. And then what we have done is like just implemented a summarize operators. And then here we have basically implemented a binning technique where we have specified the lookup window as 2 minutes. So it will bin your events in every 2-minute window. And then we, for the summarize count thing, we have basically applied this threshold, which is more than 3, right? So again, if you notice here, like this is slightly different than what the language tells you to do, right? So these are like some of the additional techniques that you have to either learn by reading some of the other queries or some of the other projects that are out there, and then see like what you want, like how to get those done in end-to-end language, right? So again, there are like many examples, can be like derivative examples that can be happen, like where you basically wants to, let's say within the lookup window, you want to say like 2 data sources and then some threshold, right? So you can make some derivation of this particular category. So this was the first example. This is the second example. The one thing that I talked earlier was like probably bringing context from other data sources, right? So some or like many times what you need is not present in one of the tables. So you have to basically interjoin your data sources and then get those contexts, right? So this is an example where we have basically written a query which looks for like a failed MFA attempts from privileged accounts, right? So now, if you know the, again, like once you start understanding the logic, you'll start developing some certain like a pseudo code in back of your mind. So in order to get like understand like how do we tag account as a privileged accounts, right? You need some criteria for that, right? So one of the way that you can do is like if you know or if you have that account list in handy, you can just pass that as a dynamic array and then look for those accounts specifically, right? But then if you know some additional data sources knowledge and other things, you can understand that, oh, there is an let's say UAV table which kind of captures and then does this store this information and then make it readily available for you every day, right? So this is like a updated snapshot of your environment, right? So what you can do in here is basically now looking for like MFA attempts. We know that is stored into the SigninLogs and then some of the other AAD data sources. What you need is like how do we basically compile criteria for privileged accounts, right? So here you can see like from line 4, we have an identity info. Here we have basically added like some loose regex. Again, you can be go like a lot more specific. Like let's say if you know you wanted to only look for a global administrator role, right? So you can basically pass out these fields and then specifically look for those group, right? But here, I think we have deliberately looked for an admin so that we can try to capture some of the other admin renamed groups in the environment, right? And then once you get that role and account UPN, then you can basically look for those accounts which were we previously identified as privileged accounts. How do we basically look further for, let's say, MFA and other type of result codes, right? So the second part is easier, and then you can figure it out. This is like a straightforward KQL query. But the first part is kind of like a tribal knowledge. We can see like you can start developing again by reading and then practicing some of the other queries, right? One of the other things I think you have noticed here is this is again like once you start writing lots of queries, you will start thinking about like how can we modularize this code and other things, right? So here we have like a same query that we wanted to run on different tables. So what we have done here is basically created a function which will take an argument of the table, right? So you can then basically pass like multiple tables which has like a kind of like a similar schema, and then similar query will work, and then basically just union both the tables together. And again, you can this can get a lot more complex, lot more messy. Like sometimes you have VM, and then you want to basically join it with the M365 device events to gather like a process events, file events, and then again coming back on joining with other data sources. So imagine like joining the like 3-4 data sources with 2 or 3 different entities, right? But once you understand the basic framework, I think it gets slightly easier in compiling those complex queries over the period. Right. So the third one is I think this is one of my favorite, and I think I really struggled like in initial my days to understand when the SQL and database world was new for me. We can do a simple joins, but the left anti-join is like kind of a special one, which is only used in certain cases, right? So here, let's take a look at let's understand like what we're trying to do here. So in this particular detections, we are specifically looking for thread signatures from unusual IP addresses which are not historically seen, right? So now this is kind of like a very generic, simple English language, right? So now how do we convert this kind of question into an KQL query, right? So let's understand here what we are trying to do here, right? So what we have done here is like we have created like a 2 tables from the same data source, right? So we are only using a common security logs here in both the cases. But here, in the first table, I'm basically looking for a historical data, which is like probably from the previous week, excluding the current day or like excluding the current hour, right? So this will basically capture all of the historical threads. Again, common security logs is like very gigantic data source, so naturally you will have to do some aggregation and some of the dimensional reduction techniques so that your results are much smaller, and then we can join that with the other data sources, right? And then the second section is where we are basically extracting the current hour events with the same criteria, just the different time frame, right? So now we have 2 tables. First one is the historical table, which is like a week worth of data. The another one is the current hour, which is like just an hour of records, right? So in order to find these details, what we are doing is like we are basically joining that current hour, which is your left side of table, joining with the left anti-join with the historical threads, which is your right side of table, right? So what does the left anti-join does? And then I think that may be like a good visualization that you can find on web to understand like what it does. But basically left anti-join will return the records from your left-hand table, which are not present into the right-hand side, right? So the not present or like not historically seen is the crucial element here, right? Again, I think this is a simple query. There are like other ways that you can also try to do this, which is basically just a simple group by on, let's say, 8 days of data, and then finding out only the current day of data or like current hour, and then with the threshold as very minimum, right? But I think this can get complex with like multiple tables and multiple fields. So I think it's very essential to understand like how does the left anti-join works, and then how you can use it for detection purposes. We have like several kind of like these behavioral type of queries in our GitHub, where you'll find like we have basically compared the historical events with the current events and then doing the left anti-join on those things. Right. Okay. So the last one is the pivot one. I think this is something that I recently discovered when I was writing basically a Mystic Pipe feature for kind of heat map visualization on the data on the Sentinel data, right? So if you see
Aswin,
here,
I have a small question about the previous slide.
Okay.
Because Mike wants to know if it's a good idea to use materialize on the let statements.
Sure. Yeah. So I think, that's a really great point. I think so. One thing that we wanted to just be cognizant about materialize is since the thumb rule for materialize is basically if you wanted to use that table in multiple times in your query, I think it makes to cache that table so that you are not executing that query again and again, right? So that will basically create a snapshot of those queries. The another thing that we have to keep in mind and then careful about using the materialize is since it's going to store as a snapshot of your table, make sure that table is smaller, right? When you're doing like a historical queries, if you know the results beforehand, which are like probably less than, I guess, like thousands or maybe that's probably a good number. But if you expect that's crossing like 100,000 or those things, maybe materialize is not like a good candidate for those queries, right? But yeah, I think definitely evaluate where you want to use those optimization techniques and other things that will help you in I think saving resources and other things. But all right, so this is the second one, the pivot. I think pivot operator is again you have seen in other examples where we have. I think I basically used pivot for the first time when we wanted to pass out the sysmon events from the event Windows security events table. But then there are like a lot more examples or like lot more use cases of pivot, right? So one of the things that I think it will be probably good if I explain. I have a sample table here, right? So I think this is very simple use case that I've taken, and you can implement this on other data sources, right? So what we're trying to do is like kind of plot a heat map and understand like within a week in which hour we saw like a kind of certain spikes or those things, right? So I needed this kind of structure from a Sentinel table, which I can basically use in a Jupyter notebook to plot this kind of heat map, right? So the idea is like basically see these kind of regions where we have like a lot more noise as compared to other hours, right? So this can be an useful anomaly detection techniques, right? So in order for to plot these heat map, I needed like this kind of data structure. So you can from here, I think you can understand the basic KQL syntax, like how we have created this pivot data structure. But the one thing that I wanted was basically reorder these columns so that it's ordered by hour, right, and not alphabetically. So if I do like a project reorder, it just assume that your columns are named alphabetically, right? So it doesn't take into account, even though I have these probably column marked as integer, when we do the pivot, it kind of lose that context, right? So this is something that I started looking at it, the documentation and other things. And then I noticed like KQL team recently added this additional operator called granny-asc. So what it does is basically it takes account, let's say like if your columns are named into the numerical fashion, and then it will try to reorder basically based on those columns, right? So now I have these columns rightly ordered here, right? So again, I think this was kind of like being a KQL curiosity. I started looking for it because I could have just done this from Python itself, like with pandas and other operators, but I sort of think like why it's not available in KQL, and then it's good to know that people have already thought it out, and then that's available natively, right? So these are kind of like again innovative techniques. I think that you can start implementing as you go forward. And then, so the couple of things that I wanted to cover was the extending KQL section. So these are like some of the examples where even though KQL is much more powerful, sometimes it has its own limitations, right? So this was like one of the limitations that I encountered recently, where for one of the threat actor blogs, we were seeing that it was specifically using NordVPN servers or like NordVPN points. So again, like there's not like a static list that's available which we can detect and then keep it updated, right? So I started looking at it. So we found that Nord has its own API. It's an unauthenticated feed, so you don't need a like API key to basically access those data. But then the challenge was it was not accessible through the external data side, right? So external data is only limited to some of the static sites like GitHub, and then some of the other website which has like a static content or like reading from a blob storage. But if you have like kind of slightly kind of complex site which cannot be rendered through external data, then I think you have hit kind of a roadblock, right? So what we did is like we have seen like a GitHub action is another way where we can basically leverage that to run like a script and then take that export and then dump it into a GitHub, right? So again, I've seen like a community blog post, and then there was like some GitHub plugin also someone developed. So community is already leveraging these things, but I think this is again one of the examples like how you can use this script, right?
This is super useful, and you might actually have a solution for something where I was banging my head against the wall last week and asking Johnny for help because what I wanted to do, I wanted to actually use the Zscaler provided CSV files. And funny enough, while I could just open Zscaler, the URL perfectly in my browser, external data would simply not return anything back. Of course, it would have been cool maybe to have the internal reason why Log Analytics couldn't bring back the file, but now you gave me a good hint. The future now looks bright for getting my Zscaler IP information into my KQL queries. Thank you for that.
Yeah, sure. Yeah, definitely. I mean, this is something that we check with the product team, and then this is by design. It's not something that's lacking in the external data. It's design in a way that it will only access those sites which are easy to render, so that from a security purposes and other things, it requires you to have like those static sites, right? But then you can develop this intermediate kind of pipelines to create the data source and then just point your query to those data sources, right?
Cool.
All right, so yeah, I'll quickly cover these things. So yeah, this is kind of like a framework where you can see like, again, I've used Python script. You can use PowerShell or any other language for that matter. The key is like you just want to execute that script on a recurrent fashion and then get that data dumped out. The great thing is like GitHub Action is free for public repository. So if you're not planning to keep it private, you can just run this for free. Like you don't even have to go through the logic app and other that complex route. Like if you have the data and all those things figured it out, right? So this is an example. One of the things I think that's currently challenging is like we cannot host these kind of watch list in our Sentinel repository because we have like a branch protection in place. And then we want the GitHub action rights if you want it to write to the master branch directly. That's something that we cannot do on the Sentinel repository. So what we are currently doing is like we are dropping this into the another repository, Microsoft.Mystic, right? So you can basically look and then go here. Here we have like Microsoft Mystic, where we have like a couple of workflows here for NordVPN, public IP ranges, MITRE ATT&CK, and all those things. So you can still like point these data sources in your queries. Like, so this was the previous query. So
And
then like once the data, yeah.
is there, because you can land the data in a GitHub repo, you can land it as threat intelligence and you can land it as a watch list. Is there a reason you chose GitHub, or was it just because you want to make it publicly available, or?
Yeah. So yeah, I think the GitHub was deliberate decision. Like we wanted to keep it as a community feed that can be used in multiple other scenarios. Like, so let's say if you wanted to probably access this from a notebook without the Sentinel or other scenarios, that can be helpful as well. So yeah, the use cases can be different as well. Right. Yeah. Again, like, whenever we talk about the feed, I think you again have to think about like how do we get those into the threat intel ecosystem so that the native rule starts working as well, right? But that was like one of the like ad hoc use case. The last one that I wanted to highlight is this is one of the great I think capability that exists today, and then probably not many people are leveraging it more. So you can basically connect your ADX via log analytics. So there are like some specific documentation that are available, like how to do that. So if you go here, you can just like pass on the ADX cluster and then table and then access those events. Again, this may not be applicable directly to the M365 Kusto clusters, but something that probably you can do this on your own, right? And then the another one is like similarly the log analytics repository, log analytics. If you want to access like a log analytics from Kusto cluster, so you can do that as well by like, let's say, performing this kind of URL and then add as a custom cluster here, right? So what this gives capability is basically join your, let's say, Sentinel data with some of the Azure Data Explorer cluster, and then you don't have to do that data pipeline things in order to do that detection scenarios, right? So again, the capability exists. Like it's about like how and how you want to leverage that particular use cases, right? So yeah, that was kind of like the things that I wanted to cover today. I think once you master the KQL syntax, like get familiar with the well-known detection methods, how we can basically practice and understand scenarios through Sentinel and community projects. So these are like a couple of good examples where you can understand like how those the community projects have developed, like how we can read those queries and learn from those things. And then lastly, the one thing that I think will definitely recommend is like share your KQL queries or other innovative hunting methods so that the community will get benefit from their things, right? I think, yeah, that's pretty much I wanted to cover today. Yeah, let me know if you have any questions or anything. I hope this has been useful for the audiences and community.
Definitely. Thank you so much.
I see we have a question from Howard.
Yeah. Also feel free to unmute yourself or no question.
Okay. Okay.
Good. Then in the interest of time, first of all, thank you very much for your presentation and your contributions, of course. I personally got some cool takeaways. I'm convinced others do as well. So let's finish this up with what did we do this month? And for that, I am going to share my screen again. What did we do with KQL this month? And I had a customer, but of course I'm not going to show you customer data, but that customer told me, like, we have like 1,500 networks in our environment. And he mentioned that to me because I was insisting, which I'm always doing, in the end, they love me for it, to actually start populating his watch groups, because populating watch groups in Microsoft Sentinel can dramatically help you in, automating false positives or the other way around, in, prioritizing your incidents that you have. Because, whether something happened in your network or from a known IP address versus the unknown IP address can, depending on the detection, make a difference. So I finally convinced him, to load all the network addresses. We're also looking at, how we can eventually automate this process. It's actually something many customers are asking me for, and I'm still in the brainstorming phase on how we could eventually create a generic solution for that. Nevertheless, 1,800 subnets, and at the same time, they also told me, that their network is highly regulated, so that it is impossible to go from certain networks to other networks. So I said, yeah, let's give that a try. So what I ended up with is, first of all, and I'm showing you here the example. So this is my watch list. And to not share my private IP address in my demos here, I just show you the other 3 entries: NordVPN Canada, Tor. So imagine, you have 1,800 networks here. You give it some tags, you give a range name, so that when you query your production data, that in addition to just the IP address and the location that we get from log analytics in specific tables like SigninLogs, but you can do the same with device network events or device network info. Just if you want to kind of see, what is coming from known networks versus unknown networks, And of course, it also might help you, as was the case here, to actually identify internal networks, but they weren't previously loaded into the watch list. So even, in terms of data accuracy, it helped us. Now, in this example, what I show you is a first query, and I started using the IP4 is in any range function. Yeah. So if I run this, what it basically does is it takes my watch list, and it goes through the signing logs, and it just checks whether there's a match or no match. Yeah. So here, no match, false. So if I just want to see those connections that were from a matched IP range, I get a true. And of course, in order to identify maybe the networks that I actually want to identify and know whether they are, actually my own, I would do the following. Now, of course, I know it's a true or false. I have some location information coming out from the signing logs. But now I actually want to get more context, because who on earth knows all those IP subnets in their company? So now what we do is another query, and I prepared this just to show you with matches in my watch list. So if I run this query now, I do another thing. I do an evaluate IPv4 lookup. And what I now get is basically I get the results of my signing logs in where location is GB or Canada. And actually, if I move over here, I will actually find the range name and the tag coming from my watch list. But at the same time, I also have signing logs coming from the UK, but apparently, this is empty. So it means there wasn't a match with my watch list. Yeah. What we found out with this particular customer, who told me that it's impossible to move across the network. Actually, we found a RDP connection coming from an internal network segment to a domain controller, which, according to them, technically would have been totally impossible. But actually, it helped us to identify a configuration glitch. In addition, of course, an administrator that should not have logged on to a domain controller at all from that location, but that's for another story. Yeah. Okay, so that's one thing I did this month. Another thing I've started doing is I came across this one. It's called the Azure Threat Research Matrix. Done by a few people. I'd like to highlight here. They've been working on this. And I thought, okay, let's see if any of those, I can actually also write the appropriate queries to it. Now, I must mention upfront that for some of the tactics, like, reconnaissance techniques, gather user information, it will be impossible to write detection queries. At least that's my finding, because read activities aren't really locked. Yeah, it's usually about when you do things. Yeah, so that's also why they as well concluded, it's impossible by means of logging to detect this. Nevertheless, I started here my GitHub repo. This is the one I was curious before. This is the one, and I know a good one, the elevated access toggle. Actually, I came across, so don't reinvent the wheel when you don't have to. So I came across this excellent article that was created by, let me quickly check. Forgot the name. Shouldn't have. Yeah. By Sami Lampu. I guess you might know him. And I've continued my way. No local resource hijack. Yeah. Here they define the possibility. Let me go back. It's called this one. So I also put a reference in here. Yeah, it's where the Cloud Shell image file might be modified. That's the one when you launch the Cloud Shell in your Azure portal. That's loading. That might be modified by a malicious actor. So what I basically did, I actually tried to simulate that activity and see. Now I'm lost in all my screens here. And see what detections I would leave behind. So if I go here and of course provide it, this might be also a good reason why you might want to turn on storage file logs, which isn't on by default. So you would have to go into Microsoft Sentinel and then enable the storage account logging. But that isn't enough. You also have to enable the diagnostic settings. As I wrote, I try to be as precise as possible, so not just share the query, but also the prerequisites. And that means in this case, I wanted to understand when someone actually tries to download or upload that image. And if the demo gods are with me, I should now, I don't know when I did that. I should see some logs here. Yeah, and there we go. I see actually an activity around my Cloud Shell image. So if I guess these are the reason why this attack research matrix is there, that it can, at least for me, inspire me, to enable additional detection rules or hunting queries. I've also tried to document the related MITRE tactic, and in the end, that of course will help you to actually drive up your MITRE attack coverage in Sentinel, as you can see here. Yeah. Good. So yeah, that was it from my part. Johnny, anything from you?
So I wanted to share is last month I've been working on parsing and ASIM parsers. I think what's nice to show is over here I've been so let me just tell a bit. Over here what I do is I started by parsing. This is WatchGuard syslog data. So with this bit I started to get all the relevant messages for network traffic, because you have the firewall, you have the auto protection, but this is the network session parser I'm working on. So I just wanted to see everything that is related to network traffic. And then what I did, I created several parsers, because this is syslog, so you don't have the Ceph formatting, so messages can differ a bit. Formatting is somewhat different. So I started with the biggest part, which was I wanted to see all messages which didn't have this message ID, and then which don't contain ICMP and IGMP. And at first what I did, I tried to parse these protocols first. But if you do a has, then it will parse faster. And when you use these parsers for bigger data sets, it can be a hassle. So I started breaking these out into 5 components. And then I extended those with the relevant information. But through the way, I found out that we found out that the parsing was becoming a bit heavy, and if you do a union with large blocks of data, then it can get really slow. And also, the question before was about the is fuzzy. Is fuzzy is by default it's a false value, but to prevent others to set it to true without thinking if you want to have it in true and false, I marked it as is fuzzy is false, because if your union gets an error, you want to know and you don't want to let it go through. So the next thing that I did, over here you've seen all the parser bits that I invoke a syslog parser. Because what I did was I, with a let statement, I created the syslog parser, and then over here I state I want to accept tables, and in this case my table contains the syslog message. So this way I can handle the syslog, the message as table. So I can use the parse-kv and I can extend and I can do all the tabular operations on my data. And in the end, I also did a project away for the syslog message, so that once we do the union, then it's clean and short, and you don't have a lot of data to union, because like I said, this is my environment has like 400,000 records. But if you're looking at data of a large company over 3 months, then it can be several terabytes. And I think, well, it can be in the 50 million or more records. So you want to keep your data as clean as possible. So by using the tabular function and then also cleaning it up and then parsing it, it will become much faster. So I took the most joy this month to learn how to use the tabular function in this case.
Awesome.
That's from my side.
Okay, thank you for that, Johnny. Didn't show me that last night. Always good for a surprise. Yeah. Okay. Well, again, thanks to our guest speaker. And for all of those who made it to our live event. As always, I'll do my best to write up the show notes. And Johnny takes care of the video recording. And we'll share all that in the next couple of days. So if you want to review things or follow up on any of the things we shared in here, stay tuned for the show notes. Next month we have another guest. Planet is Matthias Borg, also a Microsoft MVP. He's also doing a lot in the area of security. Yeah, and he will talk about KQL related topics as well. So yeah, thank you. Have a great evening, rest of the day, morning, afternoon, and hopefully see you soon back in September.
Thank you all.
Bye.
Bye.